Hello, 6153 students. This little chat will be on factor analysis. In our previous chats, we've talked about multiple operational definitions of constructs and what that may mean, some advantages, some disadvantages of that for empirical research. So let's continue that line of reasoning a little bit here. Why should a researcher care if a construct has multiple operational definitions? Well, we want to be as accurate as possible. We want to measure the construct that the community agrees is an important construct in a way that's most useful. And when different researchers measure a given construct the same way or in a very similar way, science, empirical investigation, can progress more easily. What does factor analysis have to do with it? Well, good question. I'm glad I asked it. Factor analysis helps us develop measures that jive with operational definition of our construct of interest. It helps us develop measures that are consistent with our operational definition of our construct. Factor analysis can also do another thing. The results of a factor analysis of data can, in some instances, give us reason to go back to our theory and consider refining it. When our data disagree with our theory, that could be a problem. There's either a problem with the data, maybe there's a funky data set that we're analyzing, or maybe there's a problem with the theory, and the understanding of bullying, for example. Maybe our understanding of bullying is not quite right because the numbers just don't support that. And so factor analysis can be used in two ways. It's usually, we think of it usually as helping us develop instruments that go with theory, but it could also be used to refine theory in the face of data that strongly suggests something is missing or something is not quite right with a theory. Well, let's talk a little bit more about that. Factor analysis was first developed by Charles Spearman way back in the early 1900s to study intelligence. Intelligence has been a construct that has very much interested psychologists over the years, and for good reason. Many of the origins of our field had to do with measuring intelligence for schools, going back to the time of Binet, and for the military, going back to the Army alpha and beta tests that were used to assess recruits during World War I, and of course also during World War II. And so intelligence, the measuring of intelligence is something that has been considered very important by experts, and they had a lot to do with fueling the growth of psychology as a field. So Spearman first developed the method, the statistical method of factor analysis, and this is before the days of the computer, and it was unbelievably work-intensive to do a factor analysis by hand. It was a really big deal. It took weeks and weeks of calculations, and there's always the possibility of human error, and it was really quite the thing. And yes, that was before my time. But factor analysis is useful, anyway, for finding out empirically how the questions, the items on an instrument clump together, how they naturally group together, and how they can therefore maybe be considered one factor. Maybe a bunch of items on a test, on a measure, on an instrument. Maybe a bunch of them really get at the same basic thing. Maybe they clump together and can be considered one factor. And so that's basically what factor analysis seeks to do. Um, it looks at how the items, the answers to the items on a test, clump together. Are they closely related to each other or not? Maybe these items are closely related to each other, and maybe those items are closely related to each other. Maybe there's two different main clumps that make up this construct. Let's look at an example. On the Woodcock-Johnson COG IQ test, if we subject the answers that people give to the test items to a factor analysis, we'll find that people's patterns of strengths and weaknesses on certain groups of items will be very similar. We might end up deciding that some of these groups of items measure what we'll call short-term memory. We might decide that people's responses to other items may also clump together, and we may decide to call those items decision, reaction time, speed. In fact, we wouldn't decide that. It's already been decided for us by the people who created the instrument and who refined it for us. And so the point is the pattern of people's responses to short-term memory items is different from the pattern of their responses on decision, reaction time, speed. Because they're so different, we conclude that short-term memory and decision, reaction time, speed are different factors or different subtypes of intelligence. Are short-term memory and decision, reaction time, speed different types of intelligence just because the items clump together? No. No. Just because statistically they clump together doesn't mean we conclude that those are different parts of intelligence. The decision as to which clumps form a bona fide factor is made in relation to intelligence theory. The researcher always has to go back to the theory to see which clumps in the data are easily explained by the theory and which ones are not easily explained by the theory. Because the recognition of clumps as factors depends on theory, to some extent it depends on the researcher's point of view. There are different points of view. There's different theories out there. Okay? And so there is a degree of subjectivity in the factor analysis process, and there's no getting around that. So, say you developed, when they developed the Woodcock-Johnson COG test, they went ahead, they developed the items, they gave them to people, a whole bunch of people. They conducted a factor analysis. They went back and looked at the theory and decided, oh, these things clump together, and that's consistent with this part of our theory. And those things go together, and those things are consistent with that part of our theory. And these things clump together, and wait, they don't go with any part of our theory. But boy, they clump together. Let's look at them. Oh yeah, they all seem to measure, oh yeah, they all seem similar, and they all measure, it's easy to give them a name because they're all very similar in a very clear way. Maybe we need to go back to our theory and add a component. Maybe we missed something in our theory because the data are clearly indicating that there's this other thing there that we just didn't really think of. And so factor analysis actually does two things. First, it allows us to verify the extent to which our instrument measures the construct of interest in a way that's consistent with theory. And B, or is it two, whatever, B, it can at times give us an empirical reason to go back to the theory and consider modifying it if the data disagree with the theory. And that will be an example of inductive reasoning. The specific instance of data would disagree with the theory and might make us reconsider maybe tweaking the theory a little bit. I hope this was comprehensible to you. And also bear in mind that one ought to never change a theory based on one data set. One should always replicate with other large samples, and the samples should be representative of the population of interest, of course. Some data sets are just plain funky, they're just plain weird. And if anomalous findings aren't replicated, then maybe they're not important, or maybe they are. But of course, we need to look at the data with multiple data sets. We need to analyze the test with multiple sets of participants, and they need to be large and they need to be diverse. But my point is, what factor analysis does, it allows us to take a whole bunch of items and see how they clump together, and look at the empirical clumping in comparison to the theory, and it can both make sure that the test follows the operational definition of intelligence based on our intelligence theory, and it could also be used to refine our intelligence theory if the empirical results are off, and if they're repeated over and over again, still a little off in the same way. I hope this clarifies factor analysis for you. Thank you for listening, and I will talk to you next time. Bye-bye.